Hello. Hello and welcome to the CNI Deep Dive session. My name's Bryan Boreham. I work for a company called Weaveworks, and I'm a CNI maintainer, amongst other things.
And I'm Dan Williams, and I work for Red Hat, and I'm also a CNI maintainer.
So let's just find out who's in the room. Who came to the intro session yesterday? Yeah, about half. Okay, thank you. Who is a current maintainer of a CNI plugin? Less than half. Welcome. Who knows very little about CNI? Oh,
Thanks for coming.
Yeah,
seriously.
Okay, well, I wondered about that, so we have some recap of the basics. So those of you who've been through this before, bear with us. A couple of minutes, we'll get through that. We got some stories to tell you about the kind of deeper aspects of the project, some technical details of what's been going on and life and times, and also talking about the future of the project. So let's begin the recap. So the CNI project has two major parts to it. One is a specification, and that's a document written in English, or as close as we could manage. In the same repo as that is a library, libcni. That's a Go library that's used by things that call CNI. So we call them runtimes. So the one many of you will know is Kubernetes, but CNI is cross-platform, so it's used by, can be used by Mesos, it's used by CloudFoundry, it's used by Podman, and there's a bunch of alternate runtimes that can call into CNI. And we do stress that, the cross-project, cross-platform nature. CNI is a CNCF project. Kubernetes is a CNCF project, but that's, we're all friends, but they're not the same thing. One is not part of the other. So a couple of tools. So that's on GitHub. It's all under the Container Networking Organization. The CNI repo has the spec and the library. The so-called base plugins, that word means horrible and
reference.
nasty.
Let's say reference.
And sometimes we call them reference plugins. So basically, some plugins that are nowadays on both Linux and Windows that you can use just without any extra parts, without installing servers and things like that, just using Linux facilities to fire up network bits and pieces. And as a reference, they sort of serve as best practices, especially as we evolve the system. The reference or base plugins act as a guide to how to use the new features. Who we all are. So I'm on there, Dan's on there. These are the maintainers. These are the people who show up regularly, who have commit rights to the repo. But we do get lots of contributions, and I'm sure there's lots of people in the room who have made contributions to the libcni or to the spec or to the reference plugins. And then there's dozens more plugins outside of the CNI project. Those are all CNI plugins, and we love them. We host references to a lot of them. But that's one of our aims is to make it possible for everyone to be on the same playing field. And everyone who's got a network implementation can hook that into a container runtime via CNI. That's what it's for. A little bit about how we work. The spec is quite slow in evolving.
Intentionally so.
Yeah, because we have to be very careful and really agonize over things that might break someone. We are at 0.4 on the spec. This confuses people, actually. The spec and the plugins are at different versions. Sorry. One of them evolves slower than the other. I mean,
well, and one point on the plugins is we need to rev the plugins more quickly because people find bugs in the plugins and bugs in the other libraries and stuff like that. And so we want to get those fixes out to people more quickly than the spec evolves because, like Bryan said, the spec needs to move a little bit more slowly because we need to be very careful about what gets added to the spec and the language there. But we don't want to block point releases of the plugins, just to fix a bug with something. And so we did split those two apart and create different kind of streams for the plugins and the spec about maybe a year and a half ago, basically in response to user requests for more quick updates of the plugins and not quite so much the spec.
And we're going to get into 1.0 later on in the deep dive. So for those of you who prefer pictures to words, this is where it fits. You have a runtime on the left, so maybe that's Kubernetes, maybe not. You have a container, or in Kubernetes' case, a pod on the right. And you have a network at the bottom. So this could be something that someone has set up. That this could be Calico network, or Weave network, or OpenShift's network, or something from Cisco or Juniper Network. So there's a network out there that we want to connect to our container, and conceptually the plugin is just doing the glue in the middle. I was talking to someone after the last talk, and I realized maybe I didn't explain this very well. So so in the case of my own plugin, WeaveNet, when Kubernetes calls the plugin, it basically makes one REST call because we're running a daemon and exits. The plugin itself does nothing. It's talking to an implementation of a network that's somewhere. Some of the reference plugins do their work entirely because there's something already on the operating system. Like the bridge plugin, for instance, uses a Linux bridge, which is in the kernel. So both of those things are CNI plugins, and I recognize that might be confusing to think about. But basically, what needs to happen is the runtime makes a call, which is very simple, just add to make a network connection, or del to take one away. It's configured by a JSON file, or some JSON, whether it's in a file or not. Is that me? Okay. The JSON is the configuration of what's going to happen on the network, and the plugin makes it happen. The plugin makes an interface appear in the container. So whatever needs to happen, we don't care because we're just making it possible for everyone else to play on the same playing field. Okay. I'm going to tell you a story now about a CVE, a vulnerability. I just thought so that's the recap over. I thought it'd be interesting to get into some of the life of the project and understand some of how it works. So the story really concerns the port map plugin, which is one of the reference plugins, and
what does the port map plugin do?
What does the port map plugin do? So it is for in Docker terms the -p flag, in Kubernetes terms a host port. So it's mapping a port from inside a container out to the host. Did I get it right? Okay. And it works by IP tables rules. What doesn't? So the mistake was that it inserted its IP tables rules, and this works great, in all the tests that we did. There was a problem though that they would go ahead of rules that someone else had on their machine, and in particular that could be a blocking rule, such as a firewall rule. So it just kind of depended on the order in which things were set up, and depended on whether you had a port map or not, and so on. But eventually someone realized this is a vulnerability. The interesting part was that, how I became aware of this. It was essentially people screaming at us on GitHub, saying, when are you going to fix this issue? And so we'd go like, okay, well, I personally would go, okay, tell me more about the issue. And they go, well, I can't, it's embargoed. So what we realized was it's a public project, right? We work in public, we work on GitHub. The security committee of Kubernetes, who were the people screaming at us, were a tightly knit group. They're keeping the information under wraps until they had a fix. So they weren't going to publish that on GitHub. And we sorted it out in a day or so. The fix was really easy, just don't insert append the rule. But we learned a number of lessons that week. CNI is a very critical, tiny but critical part of the infrastructure. We didn't have the communications channels. We didn't have a way to make a private build of CNI, so the fix itself could be kept under wraps. There was more fun and games in actually getting it kind of vendored into Kubernetes, but that's really down in the weeds. Ask a question if you want to hear about that. But the kind of life of the project. This is touch wood. We've only had the one CVE that I can tell you tales about. But it was kind of an exciting week with.
What do we actually learn?
Well, we need the communications channels and also people assigned to react to these things and
Well, and the infrastructure to be able to do private builds and things like that until vulnerability is disclosed.
Yeah, well, that's a work in progress, I guess. Yes. So all the kind of big names that you see up on the keynote stage, they were all screaming at me personally, and that was exciting. Okay, I'm going to hand over to Dan for the next story.
Yeah, so there are in the CNI Spec 04, there are a couple of interesting changes, and one of the big ones is check. The check verb is another verb along with add and del and version, and these four things together form the basis of CNI operations. And these are things that runtimes like Kubernetes or Podman or Cryo would call to set up containers, delete containers, and check. Check is your container healthy? And it's kind of a big addition to the spec. Yeah, is the network of your container healthy? It's something that we'd seen for a long time as a need in the CNI project. We went through a number of iterations of it, and I think it took maybe 6-9 months, maybe even a year, to figure out exactly what the right pattern there was for the check command. So based on that, let's just kind of go through it and talk a little bit more about it. Basically, what happens when Kubernetes or Docker or something like that restarts and your container is running? Well, Docker shim currently assumes that the networking is up if the pod has an IP on the primary interface of the pod. But after that, it basically kind of forgets about it, and even if it doesn't really have that IP, it assumes that things are more or less okay. So there's kind of a disconnect here between what is the actual state of your container and what does the runtime expect that state to be, and if something changes, does the runtime react intelligently to that? We thought that CNI could help here, and so we created the check command, and the check command is essentially, hey, CNI plugin, I asked you to set up pod. Well, is that pod still healthy? Is the network of that pod still healthy? Do you think it is? There were a couple of complications with that, and that's why it kind of took us, maybe almost a year to really get right and push through, because correct means something very different to a lot of different network plugins. It's things like is the IP address of the container the same as was originally assigned to that container? What if some plugin later on decided that it wanted to modify some details of the pod, and the plugin that is doing the checking right now isn't aware of those details? And that was one of the things that was kind of complicated, because if you're not aware, in CNI we have a concept of chained plugins. The configuration that you give to the runtime to say, these are the operations or these are the plugins that you need to call as a runtime, as Kubernetes, Cryo, Mesos, whatever, to set up the pod network, can be a list of plugins. And that list of plugins is, first you usually have something like the bridge plugin, and then you might have an IPAM plugin in there to do the actual IP allocation and assignment. Then you might have something like a firewall plugin to poke rules through the firewall. You might also have a tuning plugin or a bandwidth plugin to set up bandwidth limitations on the container. Well, all of these different plugins can interact in different ways, and that was one of the big things that we kind of had to discuss and figure out how to get exactly right. Is all these things do operations to the container, and they can change how the container's networking looks. And so, during the check operation, you need to make sure you account for that. So the spec language says, and this is pretty sure we copied this directly from the spec, that the plugin should return an error if a resource included in the CNI result type, which are things like interfaces, addresses, routes, MAC addresses of the plugin, other things. If a resource included in the result that was created by this plugin and is listed in the result that is given to the plugin as part of the check operation is missing or an invalid state. Now, what exactly does that mean? It's probably worthwhile to back up a little bit and talk about how, what prev result is and how the check operation works. So when the runtime calls the check operation, the spec requires that it passes to the plugin the actual object that the add call returned to the runtime. So first the runtime calls add and says set up this container, and all the plugins in the chain do their thing, and they return one JSON structure to the runtime that describes things like the IP address the container has, DNS results, routes that the container has, MAC address, a number of different things. Something needs to cache that result so that it can feed that back into subsequent calls. And those subsequent calls, the two most important ones are check and delete. In the case of check, that prev result describes the final result of the network operation on that container. And that is what the plugins in check need to take a look at, because if some further chain plugin decided to modify the results after your plugin ran, then that gets fed back in, and your plugin can see that maybe the state is not exactly what I thought it was when I set it up. And so that's why if the resource that you configured is listed in the prev result, then you can take some action on it. But if it is not listed in the prev result, then your plugin should not. What really needs to happen here is that if the plugin thinks that something is invalid, it needs to return an error to the runtime. And then the runtime is supposed to do something like tear the container down so that it can restart the container with a healthy network. And so let's take one example here. So if your container sets up, or your CNI plugin sets up a route inside the container, and then a further plugin later on in the chain decides to remove that route or change routing. Now, when that comes back for a check call to determine whether the container is healthy or not, your plugin might know through some other mechanism that it was supposed to configure that route inside the container. But your plugin will see that in the prev results, that route is not present. And in this case, that indicates that some further plugin decided to change things. And so your plugin should not decide that that is an error, because it did not see that that thing is in the prev result. Hopefully that makes sense. And this is kind of one of the reasons why it was complicated to decide how check should really work. But in the end, we did implement check support in all of the reference plugins. And so that serves as a pretty good example of exactly how the CNI project and the spec expect check to work. And again, If you see a resource in your plugin that you think should be there, but it's not in the prev result that you get as part of that check operation, that's not an error. But anything else, we would expect your plugin to return an error to the runtime, and then the runtime would take some action on that to make sure that the container was still healthy.
We're probably running a bit over time to get into.
Sure.
Yeah.
All right, we'll speed this up a little bit.
Yeah.
I think I covered that already. The important thing is there is a skip check safety valve. We could come up with some situations where this behavior could return or could result in unwanted behavior. And so you can specify in your CNI configuration that check should not actually happen. Result caching is the other thing, and this kind of ties directly in with the check behavior. So for example, how can you actually do any kind of health checking on a container if you don't know what to check for? Well, the answer is that you need to pass that prev result from the add operation back into the check operation, and kind of the same thing for del. It turns out that a lot of plugins don't necessarily want or need to cache the state that they set up, and so it's very useful for those plugins to get the result of the add operation, and then they can decide using that information what exactly they need to clean up. That's things like, for example, the subnet that the container has an IP address on, so that, for example, firewall rules can be cleaned up, and you can use in the firewall plugin, you can match on that subnet and do the right thing. So there's also config caching, and the big issue here is what happens if you want to change network plugins while the cluster is running. And this actually is a thing that people want to do. In some ways, it is more complicated than it should be, and it might not give you the right results that you want. But there was a pretty big gap with CNI around if you change that network plugin out, nothing actually remembered what the network plugin was that a particular container was set up with. And so you have plugin A, and you get a container set up with plugin A, then you swap out the network plugin, and all the rest of the containers get started with plugin B. But then if container A is removed or deleted, nothing remembered that it was supposed to be deleted with the first plugin. It would then be deleted with the second plugin. And that obviously is not going to give you the results that you expect. And garbage collection and things like that would not do the right thing. So config caching basically saves the configuration that any given container was started with, and then it will use that configuration for subsequent operations like check and del. This is, we implemented this, both config and result caching into libcni, and as Bryan said, this is the library, the Go library, that the CNI project provides as a reference for runtimes to encapsulate a lot of this behavior so that the runtimes don't have to all rewrite this themselves. So if you're involved or you write a runtime that uses CNI, this is mostly automatic for you with libcni in, I think,
as long as you wrote it in Go.
Yes, as long as you wrote it in Go. But most of them are written in Go, so that's not a huge issue. It is fairly automatic. The one thing that is not automatic with it is the config caching for delete. Your runtime does need to actually pull that out with APIs that we've added to libcni so that you can then pass that configuration back to the delete call. But it's actually fairly easy. We have implemented this check in other projects and some of the layers that runtimes use. So there are definitely examples out there, and if you have further questions on it, please ask us. Over to you.
What's next? I'm asking myself. So 1.0 is we think it's feature complete. So we want to get to 1.0. We're at spec 0.4, plugins 0.8.3, something like that. We want to declare 1.0 because some people get anxious if we're before 1.0. So we think we're basically feature complete. We therefore have a stable spec, which is what 1.0 means, really. We would like to have more complete test coverage, and we need to get our build process signing builds, so we'd like to do that. Conformance test is a great idea. Actually, this is an ask for those of you who in the audience are really interested. We'd love for people to step up to help us with that. If nobody steps up, we'll probably declare 1.0 without a conformance test. But it certainly would be a nice, really great thing to have. 2.0 is the one that comes after 1.0. So just, a taste of some ideas, things that we're talking about. Currently, CNI is a program interface, like CGI, if you're old enough to remember that. The caller execs a program, which is the plugin. And as I described, for instance, in the network I work on, all that program does is makes a network call, a REST call, to make something happen somewhere else. And a lot of implementations are like that, a lot of the bigger ones. So what we might want to do, and this has been done in, for instance, the storage interface, CSI, is make it a gRPC interface. So the Kubernetes or the runtime or whatever would somehow be aware that there's a daemon running and call it directly. That would be more efficient, give us better facilities to know what the heck's going on.
I would also point out that process execing is very inefficient on Windows. I think the Windows CNI team were some of the original people who were pushing us to think about other mechanisms than fork exec for running CNI plugins.
So gRPC, we'd like to do that after 1.0. Configuration, is currently a JSON file, and it's pretty gnarly. Exactly how that works, so something better than that.
YAML?
Not necessarily. I have no idea what a plugin drop-in is. Casey, or one of our co-maintainers, he told me what they are, and I forgot. So come on our Slack and ask.
Ask us later.
Yeah. The idea of garbage collection, so for instance, the bridge plugin, the first time you call it, if there's no bridge, it makes a bridge. And then you add, 20 containers or whatever, and then let's say you take them all away again, there's still a bridge, because there's nobody said to take the bridge away. There's no command to take the bridge away. So that's the idea of garbage collection. When there's nothing left using a thing, same applies to firewall rules and stuff like that.
It's kind of like plug-in init and plug-in teardown. Those are not concepts right now that are in CNI, but they're something we'd like to add to CNI because there's a use case and a need for those. And gRPC might be one way to do that.
Yeah,
because it has a better
easier.
idea of life cycle.
Yeah. And what do you want to see, I guess? So I just put up the slide about how you can talk to us. I'm not sure you're still on IRC, right? Slack is probably more popular. We're on the CNCF Slack in the CNI channel. GitHub, the container networking address that I said earlier, and come speak to us here. So that's, over to you now. Questions, observations?
Yep. Do we have any questions? I'll run the mic around. Please raise your hand if you do.
Thanks. So if you use the Multis plugin where you have multiple interfaces for each pod, can you have different CNI implementations or SDNs for each interface? Yeah,
I think that's the whole point. Maybe an interesting, it's interesting to me, clarification. So CNI has always supported the idea of multiple networks. Kubernetes has not, and Tim Hockin was going on and on and on about the limitations in that this morning. So Multis Multis exists to paper over a limitation in Kubernetes. Multus is taking advantage of the feature of CNI that it always supported multiple networks, and sort of one call in, multiple calls out. Yeah, that's a great example of how they used the flexibility of and openness of the system to make something happen.
You see that change? I mean, coming from the telecom industry, Multus is a bunch, and I mean, it's sort of considered as a stepdaughter in kernel.
I could repeat that, or you could repeat it for the people who couldn't hear
Coming
you.
from the telecom industry, Multus and multiple network is key, and in many respects, sort of the Multus approach is sort of a stepdaughter in the CNI context.
Yeah, it's so I don't know if everyone can hear that. You're saying that Multus is essential in some areas like telecoms, and it's considered a stepdaughter by Kubernetes. Yes, it's a CNI plugin. It's a perfectly valid CNI plugin. It's just as good as all the other ones. It's Kubernetes that has that problem.
So in continuation to the Multus plugin, you talked about chained plugin and you are introducing checks and the results, previous results. How are these plugins, which are actually delegate plugins, impacted by that change?
Do you want to take that?
Sure. You do have to be a little bit careful, and basically our default implementation for check is success. So if you don't want to implement check at this point in your plugin, or you want to do some more research first to figure out the right way to do it, you don't have to do anything. It's backwards compatible, and it will still work exactly like it currently does. If you do want to implement check, then you do need to be a little bit aware around what other chain plugins might do after your plugin. If they do alter some of the things that your plugin sets up, that's explicitly allowed by the CNI specification. And so that's why we have the wording in the specification around if you see something you did in the prev result, then you can check it. If you don't see something in the prev result that you did, then you have to assume that some other plugin in the chain changed that, and that's okay.
How do I identify change set?
The microphone.
What corresponds to me, right? How do I identify in the change set that what corresponds to me, and how do I look forward and then say that, okay, somebody next to me might be modifying. If I know in advance what the result is going to be for that modification by another plugin, I'm implicitly creating a dependency on something that is going to happen. So is there a way for me to identify in this result, like what did I do and how does other change impact my change?
Yeah, that's a good question. At this point, there isn't a good way to identify exactly what changes were made by which plugin. I can think of some ways that we could possibly enhance the CNI spec to make that happen. But at the end of the day, you can also just say, my plugin should not be used in certain ways with certain chain plugins. It's kind of up to the administrator of whatever system you're creating, whether it's a Kubernetes cluster or whether it's something else, to kind of put together the networking setup. And, you get something that you can shoot yourself in the foot with. And if you choose to do that, that's okay. Or if the cluster administrator chooses to do that, then they can do that. But again, you do have to be careful. And we sat around for a long time and discussed exactly how this stuff works with chain plugins to try to make the best approach that we could that was still flexible, to accommodate a lot of the chain plugin use cases, but still kind of keep it straightforward. So if you have more questions about that, feel free to talk to us later or engage us on Slack, GitHub, etc.
Why is port mapping CNI at all?
Why is port mapping in CNI? So essentially, we want to take all the network-specific code out of Kubernetes. So that's
and Kubernetes also wants to do the same thing.
Oh yeah, sorry, I said I spend half my time emphasizing that they're completely separate projects, and then you also might need to remember that we all work on both of them. We're all members of SIG Network and Kubernetes, and so they just wear different hats at different times. But yeah, specifically, we want everybody wants to take the network-specific code out of Kubernetes, particularly kubelet or Docker shim, and so that is why we created a specific implementation in CNI.
My point is, that is not about, so port mapping is not about stitching a network inside a pod, actually. It's something about additional IP table rules or routing or NATing that you are doing. It has nothing to do with the core networking wherein you move a width inside a network namespace, assign an IP, and just have some routes added into the container.
Well, you're entitled to that opinion.
I also would say that we are trying to figure out how the CNI specification can address features at somewhat higher levels of the stack as well. We're always looking to try to find out how we can standardize behaviors that we see as common across a number of different platforms, and port mapping was one of those things that is quite popular. And so we created a specification, or as part of the CNI specification, we've defined how port mapping can work in CNI, but the port map plugin is one implementation of that, and there are other implementations that consume the same input, which is the runtime capabilities and the port mappings, but do different things with them than IP tables and what the port map plugin itself does. So
It's not actually in the spec, is it?
It's a convention. So we can talk about the convention versus spec, that is true, but it's kind of de facto. I think maybe one more quick question, and then we're out of time.
So I have a question related to NPWG. How do you relate to that network plumbing work group? I see some interesting discussion on their Google Docs about multi-CNI support or doing something related to that. So just wondering how the CNI project relates to that.
So Network Plumbing Working Group is kind of a informal group that is part of Kubernetes. It's not formally part of the Kubernetes project, but it is related, and it's formed by people who are members of SIG Network and some other groups as well, around a common interest of how you might do multiple networks in a pod within the context of Kubernetes. That said, it is not directly related to CNI, although some of the same people are in both groups. But Network Plumbing Working Group also, in the standard or de facto specification that group developed, specify behavior of multiple networks when a CNI plugin is used to implement that behavior. So there are, as Bryan said, many of us are members of many different groups, and we all try to, kind of work together and develop things that we think will push different areas forward, but then also try to make sure that, individual projects work for a number of different use cases and groups as well. So if you want to talk more about that, I'm happy to talk more individually.
I mean, part of the essence of it is things move forward when someone shows up to do some work. A lot of people show up to demand things or complain or whatever, and I sympathize. All these people are correct about the way they feel, but it doesn't get anything done. So things get done when people show up. So the Network Plumbing Working Group is some people who showed up to do work. That's how things move forward. The CNI project is doing a particular kind of work, very thin layer, hopefully, and Kubernetes is doing other work. So just hope to kind of explain how that all works. Well, we're past time. Thank you very much for coming.